I'm going to show you and talk about linear regression and lines of best fit. You may have learned lines of best fit in Algebra 1 because it deals with lines. And I do recognize that some of the stuff I teach you with a graphing calculator might not be, I guess, applicable. But I can show you how you can create a line of best fit using like an approximation of your own as well as the perfect answer with the graphing calculator. So what we have in our first example is they're studying newborn girls. They find their average weight at the end. So these are averages throughout time. And so what they're doing is they want you to create a scatter plot, and based off of the problem, I'm going to label my x-axis as age in months. And I haven't looked that closely at this yet, so I don't know if counting by ones is appropriate to get from 0 to 15. But it looks like it probably works. I'll just count by threes. 6, 9, 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so the box is a little bit larger than what we need. And you might be curious why I'm making this like 0, 0 is because if you look at the clues in the problem, yeah, I would say it's pretty safe to say that those are the type of numbers that we want. So on the x-axis, the y-axis, that's going to be labeled as the average weight in pounds. So I'm just going to write it sideways. This is going to look ugly because I'm really bad at writing sideways. And LBS, just to give the units there. And we have to go from 0 to 25. So I don't know, it doesn't look like it's going up to 25, so maybe count by twos. 2, 4, 6, 8, and then right here, just for clarity, 10, 12, 14, 16, 18, 20, 22, 24, 26. And I care about 26 because I said going up to 25. So as we create a scatter plot, we're starting at 0, goes up to 7.2. So that's going to be about right here on my scatter plot. At 3, 1, 2, 3, going up to 11, really close to 12, 11.8. At 6, 4, 5, 6, up to 15. I think that's about right here. 9, so 7, 8, 9, up to 18.2, so barely above that line. 12, 10, 11, 12, up to 21, really close to 22. And then 15, really close to 25, so about halfway up there. So if you notice, we could, okay, so check mark right there. That's what we just did. And they ask you to use a ruler. I'm not going to quite use a ruler. I'm not going to pass out rulers either. If you have one, cool. Otherwise, we have this shape tool right here that I could just draw a line connecting from over here to somewhere over here. So you notice that they're not going to fit perfectly on a line, but the line of best fit, you want to have some that are a little bit above, a little bit below. I mean, you definitely don't want your line to be like this, where it's not even close, or over here that's not even close. That's why he's asking you to use a ruler that maybe looks like this. And so what that's doing is, yeah, there's as many data points above the line as below it. So again, I'll just put a little check mark there. Okay, congrats. And so what you can do is you can pick a few points on your curve. And I always tell students to try to pick some points. Let me change colors so that you don't think that these are the actual points. So these blue points are points that are on my line of best fit. And I'm just trying to pick points that look like they go through the corner of a grid. And here's the thing, is there are lots of correct answers if you're doing this by hand. If you're doing it using a calculator, there's only going to be one answer. So as you notice, I picked the point that looks like 412, and this point up here appears to be, let's see, 9, 18. And so now I can use the tools we've learned in previous lessons where I can find the slope of that. So the slope would be y2 minus y1. And you might have different answers than what I have. And I might teach this in class and have different answers. But then from here, and that's the thing, is it tells you to round your answers to the nearest tenth. And if you actually divide, that would be 1.2. So then your slope, in point slope form, whether you use the first point, which I typically use, or the second point, y minus the y coordinate equals the slope, x minus the x coordinate. And then as I distribute 1.2 into the problem, so 1.2 times the negative 4, but I also have to add the 12 to the right side, and the y-intercept would be about 7.2 in my problem. So if you are at home watching this video and getting this lesson down, my y-intercept came out to be about 7.2. But the things that I'm going to be looking for when I grade this work is that your slope is positive, because this is definitely a positive, as the x values increase. Oops, forgot to close that. My y values increase, and the y-intercept should be somewhere close to 7, because the average weights of these girls, these baby girls, started out at 7.2. So it should be close to this, because you might have a different approximation than what I came up with. So now what I'm going to do is show you how you get the exact answer using a graphing calculator. If you don't have a graphing calculator at home, I'm sorry. What you can do is just follow along. So what you would do is hit this stat key right here, hit enter on edit, and you can start to enter in these data points. So the first list would be the x values. And just as a heads up, if you ever have a list in here, how you clear out a list, you can either type over it, but if you have extra data points, you might have to hit the delete key. But if you ever go up here, let's say I put in an entry real quick, that's wrong. You could delete or write over it. But if you go up to the list, do not hit delete. You want to hit clear and then enter. Otherwise, it'll actually delete the entire list off of the computer, and it takes a lot of off the calculator, and it takes a lot of button mashing to get the list back on there. Okay, so once you have this, so hopefully I typed it in correctly. Double check that you did. You can see it looks like an ordered pair when x is 0, y is 7.2. So now what you want to do is get out of there. So second mode to quit out of there. And then go back to your stat, but then you want to calculate. If you notice, your fourth option here is a linear regression. That's why we call it that. LinReg. And I usually do this one. The option 8 also does the same thing. That's how you might see it in statistics. So just hit that button. The X is where my list 1, my Y is where my list 2. And I'm going to do this. I'm going to hit alpha trace. And I like to store that equation into my graphing calculator. And so you don't have to do this. But when you hit enter, you'll see the better answer than what I came up with. Because remember, my answer was y equals 1.2. Well, the better answer is y equals 1.141. And then the y-intercept is about 7.943. And if I go back to the directions, it's asking for the nearest tenth. So if you did to the nearest tenth, you would round to, whoops, not 1.2, because the 4 is smaller, so it would be 1.1, and then the y-intercept is 7.9. But that's what I mean. There's only one answer if you're using the line of best fit here versus using that answer there. So one more thing with the graphing calculator, and again, you might just be following along here, is if I go to the graph, you can actually see the line of best fit as it's stored in the window that I have in my calculator right now. But you can actually change your window to make it look like what we had from 0 to 16. counting by ones, and then your y values from 0 to 26, I think is what we did, counting by twos. So now if I hit the graph, that line looks pretty good. And one more thing is you can actually hit second y equals, and you can actually create a scatter plot with your calculator, and you just have to turn it on. It already has it stored as list 1, list 2. You can change the color if you want. But now if I go to my graph, you can actually see my scatter plot and how it relates to the line of best fit. I know I went fast over that, but I don't think you guys have calculators at home to do that. So now what we can do, and why we would do that, is now we can use that line of best fit we just came up with. Remember, y equals 1.1x plus 7.9, and we can plug in 10 in for x and see what you would estimate your correct answer to be. So it would be 1.1 times 10 plus 7.9, and I'm assuming you can do this in your head. 1.1 times 10 just moves that decimal over 1 point. So 11 plus 7.9 would give you 18.9. So what we just did is, because 10 is within, it was between 0 and 15 months, that's what we call interpolation. Interpolation. And that's usually accurate because it's within the data points that we have. If you're still confused, you see how we collected data between 0 and 15 months, and 10 was right there. So that would be interpolation. Extrapolation would be if we were on the outside. I don't know if you've ever heard the word extrapolation. It doesn't look like they even talk about it here. Oh, there it is. I knew it was on here somewhere. Extrapolation is when you're outside the range of input values. So that tend to be less accurate, because I hope you would think about how a baby girl would stop, after being 100 months old. At some point people stop gaining weight, or they should stop gaining weight. As we look at this, so after 2 years, think about how that's actually 24 months. So if I did the same thing, a 2-year-old girl, if we continue to use that data, I'm not going to rewrite it, plus I'm running out of time on my video to try to keep this short. I'm not as good as doing 1.1 times 24 plus 7.9. Whoops, too many nines. So a 2-year-old girl, maybe she does, or maybe that's a bad estimate, but would weigh 34.3 pounds. But that's called extrapolation because 24 months was outside of the 0 to 15 month range. Okay, so here's another thing. This is actually what we call in math and statistics a line of best fit. It's the least squares regression line. And they collected data here. They want you to practice again with a graphing calculator using this. So I might just pause the video and quickly type that into my list 1, list 2. Alright, so I jumped ahead and typed that in. Remember, you quit out of there. Go back to your stat, and this time you want to go over to calculate your lin reg. List 1, list 2. You could also store this equation again. This is just an option for you to calculate. And you have 1.3x minus 28.0. Well, it's asking for nearest hundredth now. So let's go ahead and do that correctly. 1.33x minus 27.98 if you round correctly. So if we use that equation, now what we can do is we can figure out for 30 inches long, and this is why I like doing that store reg, is now I could actually go to my table of values. I can actually jump to 30 for my table of values to see that it should be about 11.78. And then I can set the equation, and then I can jump down to 52 for 40.94.